Hello, everybody. It's 7:38 p.m. Central Time on the 7th of February, 2023. It is Tuesday night here in the United States, getting ready to roll over into Wednesday. Internationally, it's already Wednesday. Hope you're doing well throughout the week. It's been a pretty rough week, seismically speaking. If you have been paying attention to the news, you know about what's going on over in Turkey with just thousands of people killed and tens of thousands seriously injured, maybe even 100,000 injured. It's a lot of people affected by this event, not just in Turkey, down in Syria as well, not getting much coverage because of the location and so forth. But let me get a display capture turned on here just so you can see what I see ever so slightly better. We're going to be talking about a spread of earthquakes that's gone across and out of Europe, out to the mid-Atlantic ridge. There's an earthquake that has fallen off the feed already, just over 50 earthquakes, 50 earthquakes on the European feed. One up in Scotland, next to something that I think I want to show you here. So let me just close this window, get a new window open. We're going to jump over, I guess. We can go to my YouTube community page or to Twitter. I've made posts on both. So here it is. Okay, here's the graphic that I posted. You can see here's our 2.1 earthquake that got reported up in Scotland from the Europeans, 8-kilometer depth. We'll get the coordinates on this and put this in on Google Earth so that you can see what's up there. But first, let me show you the rest of the earthquakes. A new 5, 4.9 USGS, struck right down here at the Greece border with Macedonia and Albania, also Bulgaria over to the east. I'll highlight the earthquake there because there's so many others on the feed, or maybe we could even just turn down the rings temporarily to see that. There, right on the back side of our arrow, a new 5 struck. Then you see this earthquake up here in North Italy marked as a 3.2. I'll take you back over to my YouTube community page where I documented it at the time that it struck, and it was listed as this, 4.0. Here's our stats from the European page. Decided to start copying that because they're changing the magnitudes by so much. Not just the Europeans. It's happening all over the place. Anyway, 4.0 struck. So really what you see here is a stepping stone path of same-sized earthquakes. 4.9 down at Greece, Bulgaria, Albania border region, Montenegro as well, and then 5.0 all the way out at the other end, out at the mid-Atlantic ridge. In between, a new 4 popping off. They downgraded it, whatever. But then, after that, the new earthquake struck up in Scotland, which I want to pull up and show to you because it's right next to a volcano up in Scotland that most people don't know about. So we'll put it in on Google Earth. It's called the Augnaha Crater up in northwest Scotland. Here's the earthquake epicenter. We'll look at that in a second, but this is Augnaha Crater. And in the middle, they have the volcano cabins that you can go stay at. That's really cool. I might have to go there. If you guys live anywhere in the area or if you go on a vacation there, why not? Look at it. It's a volcanic crater in northwest Scotland right next to the Isle of Ig. Now, here's the earthquake epicenter. Check it out. I think there's another one, guys. I think this is one, too. Undiscovered. Think about that. Look at it. See it? It's not just a mountain, guys. It's right next to the other one. There's another one. Just like the other one. I've got my hippie roots in me already talking about going up here to Scotland, right? You got a bunch of Scottish hippies up there right now, I think. Okay, anyway, check it out, guys. Hey, what is a Scottish hippie? They all got beards to me, you know. Okay, anyway, we've got an earthquake up there right next to the volcano, and the volcano is there because there's a weak point there on the edge of the plate. The weak point on the edge of the plate is a transfer point. That's the reason there's volcanoes there to begin with, that go back to the start of the whole continent here. Goes back, those supposedly go back, modern science says, 300 million years. You got to say it like that for it to be believable. The time frame, I mean. But anyway, up here, right along the coast, right along where the fractures are, right along where we would expect, where we have an arrow. The reason we have an arrow there is because we've seen in the past a transfer that comes out of Europe when there's a big push, goes across Scotland and Wales, goes up and dead ends up into the North Pole and Iceland. In my last update, I neglected to mention Iceland. I have to talk about Iceland. Iceland starts to see a major increase in seismic activity after stuff like this happens down in South Europe. In the past, we've seen 5s, 6s. We tend to see a spread of earthquakes go up and across Italy and around Europe, like I already issued warnings for. Go across Scotland and dead end up here, right at the X. And a lot of times, they'll issue volcanic warnings even when it's seismic. They'll see an increase in seismic suddenly come in, and they associate it with the volcanoes there, and they'll issue a volcanic alert even though there's no volcano that erupts. Other times, when it's a huge push and it comes in dead end straightly into Iceland, we get volcanic activity that increases within a few weeks or less after the wave spreads out across Europe. So let's recap. A new 4.9 struck down here right along the border where we issued our warning. We issued our warning for Albania, Montenegro. This is Albania, the little country, and I said I was hoping for earthquake activity to strike over in the Adriatic Sea here in between Italy and Albania. We warned them for 5.9. Now, when this kind of stuff happens, when a 5-ish type earthquake strikes and the USGS comes in and downgrades it to a 4.9, it was originally a 5. I'm looking for up to a 5.9, and we get a 5. That's the earthquake we're looking for. I'm trying to get it within 1 magnitude, and this is within 1 magnitude. But is this the earthquake we're looking for is the question. I don't think so. I think we're still going to be seeing an earthquake breakout in between where the 4, which they downgraded to 3.2, struck here, and the 4.9 here. There's a halfway point between the two. Do you see it? It looks like a oval shape or an eye. Okay, right there is, guess what? Where I issued my warning for Italy. Off the coast of central Italy, Adriatic Sea. That's directly in the middle of this, where they overlap, where the rings overlap. So we watch for several more days, 6 more days, for the potential of up to 5.9. Now, down to the south, are we going to get our second 5.9, or is this it? Look, this is now into a guessing game on the USGS end, on the magnitude. If that earthquake was just a little bit bigger, let's just say it was a 5.3. Maybe it was. Anyway, they downgraded it. But if it was a 5.3, I'd say yes, that's the earthquake we're looking for. If it's a mid-range 5, this being a 4.9, I still think we're going to see 2 5.9s or something very close to it strike at that center point right here, okay? So keep watch next 6 days. Now, same time that's going on, we have a creeping out of small earthquakes. 2s and 3s going up around the outside edge of Romania. They struck yesterday. I showed them in my update yesterday. That's been followed by a new 2 up here in Scotland, letting us know 2s are going around the outside edge of the plate right now. That's way low. We're expecting 5s, 5.9s, to go around the plate. Now let's talk about the 5 out here at the tail end, all the way out at the mid-Atlantic ridge. Think of it like bookends. On one end, we've got the big 7.0 level activity. Then we have a stepping stone path of 4s going across the plate. They downgraded it, whatever. Let's go back to my graphic here, over on my page that I shared. There it is. So, going across Europe this way, you can see it. It's a trajectory going underneath the plate and coming up out here on the red line. Well, here, you don't see the red line. Let me get that open for you. USGS plate boundary map should show it to us here. There we go. There's Europe. There's Turkey. Our flow going out of Europe, going up through Italy. 4.0 earthquake struck up here. 4.9 earthquake struck down here. And trajectory like a ramp, jumping out and curling. We expect this to go across and out and up this way. So striking out here. We're experiencing an increase out here on the mid-Atlantic ridge as the wave is trying to make its way out to the edge of the plate all the way across. Now it's reflecting back into itself, I think. I think that's what's going on now is we're really seeing the standing wave build. We're going to see our new 5.9s to 6s break here on the plate boundary. We already saw a new earthquake up here in North Scotland, letting us know that there's energy going around the outside edge of the plate. The craton, I mean. So we got the activity in Romania we were looking for. And I don't know if Poland got hit. I think Poland did get hit. That's another earthquake that's not on the screen here, isn't it? Yep. I have to go over to the European feed over on their page to find it, but a 3 struck in here earlier today. I did not get on and do an update on it. You guys would have literally had to see it here on the screen, just roll by in Eastern Europe, if you know what I'm talking about. If you're in the chat room and you know what I'm talking about the 3 that struck today in Poland, press 1 in the chat. Just, I know there's a bunch of you that are paying attention. Anyway, if you did not see it, either don't press anything or press 2. Anyway, so back to it. 3 struck here earlier today. A swarm of 2.9s broke out here last night. So 3s went around the outside edge of the plate, really. Then a 2 struck here up at Scotland next to the volcano. So that's a low amount of energy to go around the outside edge of Europe right now. It's going the way we expected, but it's all still trapped here in Turkey. Now, Turkey, turn off the rings. Take a look at the quakes. Check this out. Look at this. Seriously. Okay. First of all, line of earthquakes goes down right across into Syria. And previously, you don't see them all on here because the USGS is not reporting them. Going down through Lebanon, and look, Israel got hit. Or Palestine, I'm sorry. So we're right here in Palestine. Let's get the information open, and it's from the Dead Sea region. If you listened to my update yesterday, when the earthquake struck in Turkey, I brought up the Dead Sea. I even warned for watching at the Dead Sea for potential activity. Why? Well, here, first of all, here's Palestine. You see the red line going around. This is like where everybody's talking about, right? Like, internationally controversial, but anyway, that's the name of it. We've got Palestine, Israel, Jordan, and Dead Sea. Dead Sea is down at negative 1,363 feet. It's 1,300 feet below sea level. It's the deepest spot on the planet, on the surface of the planet, not counting the ocean, of course. And what happens here is the Jordan River flows in, and it's so low down here in the desert, and of course it's the desert, check it out. So we get high temperatures, and it being so low of an area, the water evaporates quicker than it flows in. So the water comes in, it doesn't ever really fill up, but it deposits huge deposits of salt that flow down out of the rocks there. And let me zoom in and show it to you. I know that looks just like waves, but you'll look on across the whole thing and it's just nothing but solid salt, icebergs of salt, if you will. This picture really isn't doing it justice. I mean, there's open water too, but on the edges, it's so much salt in there. You get the Dead Sea salts. And I'm not saying that's what's related to the earthquake. I just have to bring up the Dead Sea as the lowest point on the planet. Why? Let's show you. We'll go back over to the USGS plate boundary map and show you. Egypt, and then goes up to the north and meets up with our earthquakes in Turkey. Let's follow that red line down to the south. Look where it goes. I'll be darned. It goes right through the Dead Sea, right on the side of it, the mountain range just to the west. Now there's a fold that's happening there, and that fold is happening between Saudi Arabia and the African plate. That fold, that deep basin that the Dead Sea is in, there's a fold that goes all the way up. It's really, let me show you on Google Earth again. We're negative 1,300 feet below sea level here, and all the way up here. We're still negative 200 up here. Lake Tiberias is just, here's 0 foot right to the east of Lake Tiberias. So we're even with sea level right in here. So it's really low. It's a bend in the plate. And then as we go up to the north, then it starts to rise again. And I'm showing that to you because the earthquakes have crept all the way down to the Dead Sea. I brought it up in my last update. Now it's gotten hit with a new 4. Pretty rare. It doesn't happen very often. Only happens when there's a lot of stress either coming up out of the Red Sea. When I say stress, earthquake activity. The passing wave is going up out of the Red Sea and sometimes strikes there. In this case, it's being affected by the area to the north. Take a look at the area to the north on the USGS map. You can even see it. The bend of the plate boundary of the African plate going across over into Europe itself and Asia, right where the two meet, there's a break happening there. This is just 1 day's worth of earthquakes. Let's look at the whole week. Let's look at the whole week, 4.5 plus. Take a look at it. Now you can see it. It looks like a giant letter T or a letter J. That letter J extends down to the southwest, following the curvature of the plate boundary towards Cyprus. This matters. This would be a new plate boundary forming or an unmapped plate boundary breaking. That the USGS has no connection point between the plate boundary coming out of Iran and going over to the west into the W-shaped plate boundary in the Mediterranean and Turkey. Nothing's there, but we've observed earthquakes jumping across from this point to this point. I've showed it for 8 or 9 years and talked about it at length about the lack of a plate boundary being there, and there needs to be one marked there, and they haven't marked it there because they said there is not one there. And instead, look what's breaking. 2 7.8s, multiple 6s, and it's in the shape of the 3 plate boundaries that meet there, or 2, Africa, Europe, Saudi Arabia, and the greater Asian plate over to the east that makes up all of Iran and so forth. But they all meet right there, and it's breaking. Now I'm looking for the flow to go down and around and back up through Greece, Albania, Montenegro, Macedonia. And so far, that's happened. We just got the new 4.9 to 5 right here at their border. We got a new 4 up here at North Italy. The spread is starting to take place. It's in the 4 and near 5.0 range. The whole plate boundary is breaking, though, and I think that is probably the biggest news that you're not going to hear on any kind of professional talking about it. Nobody's going to want to go on a limb and say that that's happening. And the media is not going to talk about it because of what it means. It means that a new plate boundary is forming between multiple plates. It means more earthquake activity is likely as the energy spreads across. Look which way it's breaking. It's breaking in a, well, what would you call that? A 2-prong shape, a Y shape. It's going over to the west. Now, look what's happening over to the west. See this stack of earthquakes? 6, 4s, 5s. This is a new spot. A new spot compared to what? A new spot compared to the 2 7s and the multiple other 6s. The 2 7s struck down here, right at the border, and up here. Now, look, over to the west, it's dead-ended into whatever is over to the west. So at this point, a new earthquake just struck there as I'm talking. Let's get the info on that. It's a small one. It's a 3.4. We're swarming out there. It's a big stack of earthquakes right on top of one another. You see how they're going up in a big stack there, numbering out at 6? The wave that's trapped in here is impacting into something. I just want to see what it looks like actually from topography. So this is a real-time lookup. I don't know what's there. I know we've shifted, and I'll show you the original earthquake location, the second earthquake location, and this spot now we'll compare. Farm fields, of course, but greater topography shows us what? What are we impacting into here that would stop the seismic wave over this way? Oh, wow, okay, look at this. Look at the shape of the mountains themselves. They make a southwest to northeast. Kind of a block there. It goes down into here. And then comes back down this way, down in the plate boundary. Interesting. Okay, I just wanted to see what was there, if there was anything of significance there. Goksun is the name. Goksun is the name of the spot getting hit now. Now I need to measure over to Elbistan, which is 40 miles east where the 7.8 struck, the second one, 7.5 to 7.8, struck there, about 40 miles. We'll do that in kilometers for everybody else. 60 kilometers over to the east. And then down to the south, right down here at the border, there's Gaziantep, and it was 60 miles. There we go, about 60 miles south. Also, to seal the deal that something's going on, look how far east. Look at this line of quakes. Do you see that? Again, 4s and 3s as far east as, well, we have to measure. This is the way you do it. You have to measure it actually physically to see how big of an area is shifting at once. So far, we're 40, 60, and wherever we're going up here to the east, northeast. Now, that's in miles. 40 miles, 60 miles. All the way up here, okay. All right. We're back here on the mountain range that connects, that I always said connected over to the east. You see it. You see the mountain range, how it goes over to the east and goes over to the west, southwest like this. Okay. Wow, that's way far, guys. Look how far that is. going back to the earthquake epicenter next to Gaziantep, it's 200 miles. That's 200 miles, 318 kilometers. Okay, so now we have a rough estimation of the area that's moving. We can go 40 miles west of Elbistan over here, and that'll tell us the full area that's moving. Goksun was it, right? Okay. All right. So 206 miles across and 60 miles south at least. Or wait, it's more than that. It's more than 60 miles south. Look, we go all the way out here into the ocean in between Cyprus and mainland. Let's just kind of eyeball that and see how far it goes down to here. 350 miles. Kilometers, 570. So that's a huge area, guys. What I'm getting at here is that an area 350 miles or 500 something kilometers across is shifting and breaking. And the area really, to compute the square mileage, you would measure it also 200 miles over to the west. To try, again, to get the square mileage on that. I don't know what it would be, but it's this whole thing right here. Well, what's this whole thing right here? We'll go back to the USGS map. This. And what's that? That is the northeast edge. It's a broken edge or a small pinnacle edge of the African plate that's breaking and connecting across and leading right over to here, to the east. Right to the edge of the plate boundary. That's a big deal. I'm documenting it for people in the future to at least see that it happened and that at least it's connecting across now. Let's take a look at the rest of the activity around the planet now that we have this in-depth look here at Turkey. My warnings for the area at the Adriatic and at Romania still stand. Back over to the West Pacific, we have multiple new deep earthquakes which are raised high off the globe for easy identification purposes. We're going to zoom in on one and show you our letter D that's there. These are forecast area points where we look for new deep earthquakes. And like I said, deep earthquakes are identified high off the globe. We'll zoom in over here and you're going to see, here's our other letter D, and right next to it are new deep earthquakes, forecast point. Deep earthquakes are happening below the plates, which then we watch for shallower, larger earthquakes to come up to the shallow portion of the plate up above, to the surface, or close to the surface, and see a shallower, larger quake. Here's another deep earthquake up here by Japan, right next to our letter D. And next to it, we have a deep 4.3, first of all, that struck last night. Next to it today, 5.4, struck down here next to Micronesia. Micronesia got struck by a 5.4. 5.2 struck north of Guam, just north by a few miles. Also a 5.4 struck over here at Solomon Islands, and a 5.4 to 5.5 struck over here at Java. 5.4 to 5.5 at Java, 5.4 to 5.5 at Solomon Islands, 5.4 to 5.5 over here at Micronesia. Sure is a lot of 5.4 to 5.5 going on. Why is that? Let's get all the smaller earthquakes out of there and I'll show you. It's like a triangle of earthquakes going across from north of Guam, all the way over here to Indonesia, and back over to Solomon. What is this? Let me show it to you. That is this. From here to down here to over here. It's the plate boundary meetup at a S-shaped plate boundary bend, which you can see much better on Google Earth than you can on the USGS plate boundary map. It looks like a giant letter S. This is where all the plate boundaries meet up. And we're getting a series of earthquakes going from up here at Micronesia, down here next to Indonesia, and all the way back over here to Solomon Islands. Something's going on here in the middle where the plate boundary meets up at the S-shaped bend. What's going to happen there? Most likely a larger earthquake, something larger than all three 5.5s on all three sides. That would put us into Papua New Guinea going into Indonesia as our center point to watch for the new break to take place. Now, this is on top of my other warning that I still have going for a few more days down here north by northeast of New Zealand. This goes up across the Kermadec Islands, going further north up to Fiji. And we're looking there because it's the antipode of the big one on the other side of the planet. It's the opposite side of the planet of the big one. So we watch off the coast of right out here, New Zealand. Technically, that's not really the coast of New Zealand. That's way offshore of New Zealand. But all eyes point towards the West Pacific now. If you take in the other 5.4, well, now it's 5.3, that struck all the way up here, then you should be able to see it. It looks like a giant triangular target where the middle point is where we're going to watch the middle of that giant triangle of same-sized earthquakes. I mean, what's the difference between a 5.3 and a 5.4 anyways? 0.1, of course. But the distance, it's not that the 5.3 up here in Kamchatka, Russia, is somehow causing this 5.4 down here at Solomon Islands or this 5.5 over here at Indonesia. It's that all three earthquakes are caused by a spread of the same size force spreading out that far in a day, 2 days' time at the most. Now, guess what? 5.4 in the middle, 5.4 or 5.5 on either side, 5.4 up to the north. If you take this 5.4 plus this 5.0, it equals 5.5. Over to the east side, it's all fives going down towards New Zealand, and this is the spot where the antipode is. Going across the plate, check it out, 5.0. Where did it strike? Right on our arrow. Now you'll notice there is a north and south facing stair-stepped fracture zone that goes down to the south and further up to the north. This makes up the Nazca Plate down here, the boundary between the Pacific and the Nazca Plate. And we have our arrow there for a reason, as well as Leviathan, the force coming up from down below, the force from the deep. The force from the deep. Earthquakes that spreads out and across and follows our arrows. Now think of this like a bridge, the arrow, and think of the earthquake like a train passing across a bridge. As it goes across the bridge, it starts to vibrate. The trestle starts to shake and so forth. Now we get over here, I'll show you on the USGS map what we're going to run into as we're going across the bridge. This, a spot to go to the north and a spot to go to the south. Nazca Plate, dividing point. Coming across, hits this, goes to the north. And around, following the plate boundaries, through the Caribbean and north of South America. Now when we get an impact in the middle like this, coming across from over here, a wave. Once it gets to here, it breaks two ways, north and south. In the middle, tension is created on the east side, and we see an outbreak in the middle, south, and north, and it tends to be greater than what's coming across. So a 5 coming across means something slightly bigger, or way bigger, strikes at where the train makes impact to the mountain. It goes around the mountain. It should be coming around the mountain. And then down to the south. Okay, that was super cheesy, man. Let me get stupid. All right. Sorry. Down to the south, our arrow points into Chile again. I would look out here on the south arrow for a similar sized earthquake to get reported. There's the tiny island of Rapa Nui, the tiny volcano Rapa Nui, Easter Island, a little speck of a dot there. I would look right across there for a similar sized quake. This should evenly distribute out on both sides, coming from over here, okay? And impact with something bigger. And now when I say something bigger, it could go up to a magnitude larger, which puts us up to 6.0 at both spots. Now in the middle, we tend to see new deep earthquakes strike at our letter D, which then tell us what to look for magnitude-wise in South America. Central America, Caribbean, I want to show you guys something, and we're going to go over to Google Earth, and I'm going to turn the Earth a way you never look at it. Probably a way you're going to have to start looking at it at some point here in the future. Once everything shifts. The weather, I mean. Never mind. Okay, so we're looking at the world this way. And I want to draw your eye to South America, going around the north side and going around the south side. You see it? It's like a float point. It's the plates, though. Now, this is a 20,000-foot drop-off on the right-hand side or the east side, whatever you want to call it. Actually, it's the north side, but on the right-hand side, 20,000-foot drop-off. Puerto Rico is right here on the right side. Haiti and Dominican Republic, Cuba, Florida. Okay, anyway, we drop off 20,000 feet here, and it's shaped like that. I'm going to turn on our volcano place marks. Well, there they are. See how it goes in a crescent shape? Those are all. Okay, now let's go down south. Same thing. 20,000 foot between here and here is a 20,000 foot drop off. And I'll be darned, a bunch of volcanoes in the same shape, same crescent shape as what's up here in the Caribbean. So when I look at it this way, I see it's like bent molasses or something, going around the outside edge, flowing like a slow river, pushing over. Coming over from what? Well, in this case, it's coming over from the Antarctic plate, the Pacific plate. It's coming over from the Cocos plate, North American plate, but something's pushing this. What's pushing that? What's causing that to be 20,000 here, 20,000 here, volcanoes down here, volcanoes up here, in the same shape, about the same distance, and about the same height? Let's turn it back this way. What's flowing around South America? The earthquakes. That's the same path and trajectory that the plate boundary takes, but the seismic wave is flowing around like this is a rock in a river. And in the middle, just like you'd imagine a rock in a river, the middle part of the big chunk of rock is going to receive the most tension or power, but it's going to distribute out around it. And that's what's going on either side. Apparently, it's done this for a long time. Again, Antarctic plate is doing it, and the Caribbean plate is doing it. But really, I think they're all really being bent and pushed by the seismic wave that's coming up from down below, spreading out in both directions. It's a huge discovery. It was denied, too. That's the funny thing, is that people said I was faking the earthquakes. That's actually why I started my live stream. So that I could show that I wasn't faking the quakes. You could look them up live. We could have a copy of Earthquake 3D open. That's what their explanation was. They said I was cherry-picking earthquakes to make it look like there was a spread going across the planet. So me trying to prove myself. Whatever. Here we are, same-sized earthquake spreading out across the whole planet. West Pacific as far north as Kamchatka. We could talk about this earthquake up here north of Russia. Is up in Russia. Let's go take a look. The Laptev Sea. The Laptev Sea, as we call it here in Missouri. No, it's Laptev. I don't know what I just said. Something about my name. Ochin Harasha, Tavarish, ha 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 ha. Okay, all right, okay, all right. Do you guys know about the over-the-horizon radar stations that the Russians used to have out here? Over-the-horizon radar is a very powerful type of radar that's used up in the Arctic especially. I'll have to see if I can find some of their... Yeah, maybe this is one. Maybe they got one up in here. One of their over-the-horizon radar stations. Yeah, it looks like we got that military up in there. This would be Russian. Oh, man, can I find it? It'll look like a big dish, basically. But it's pointed sideways, so it might be kind of hard to see. Guarantee it's up here. I'll just have to... Ah, man, Jim Lee used to have a great database of these. Anyway, they're stationed right along the ocean here, and they're all along... We have them, and they have them. Over-the-horizon radars. Well, there's also a Russian submarine facility out here that many people have talked about. It's not just me. And they use very low frequency, high power, very low frequency. I do not have any of the information on their facilities here. None. It's actually one of the locations where we don't have much info on what they're doing there. But I can tell you that the Arctic sea ice tends to melt here regularly every year in the middle of winter. A vast area melts. They say it's from global climate change. Hold on. Global climate change. That's right. Gotta say it's serious. Because it's serious. Anyway, a big undersea or underwater base here for submarines that's been confirmed by many people. I just don't know exactly where it is. It's not marked on Google Earth. Anyway, the area melts there, and I think they're two are related. I think the very powerful high frequency and other low frequency generating facilities fully capable of melting that ice over a vast area. No meteorological nerd will agree on that, though. You'd have to find a conspiratorial nerd to get you to agree on that. But we're not looking for consensus in science on stuff that I know is true. Now, let's go across up into Alaska, down into the United States, and talk about what to look for and what's happened here in the U.S. First of all, got to bring this one up again. 4.0, 3.8 earthquake struck right here at the New York border. Now, interestingly enough, this is in Buffalo, New York, and this is right next to a bunch of Indian mounds that have been torn down, and they built power stations over, apparently. How ironic, right? But the earthquake itself, we talked about watching for 3 days ago. Now, 3 days ago, there was a train derailment that happened right here at the Ohio-Pennsylvania border. 50-car train derailment. Some kind of vinyl chloride or something in each car. Toxic. It blew up, burned up. 50 cars derailed right here at the border, like I said. And when I got on, this earthquake wasn't there. I talked about, look, whenever we start to see movement on the edge of the North American craton, let me show you the craton diagram. And let me get a display capture open here so we can overlay the two. On the East Coast, up in the Northeast, when I heard about the train derailment, I said to my wife first, then I got on and talked to my viewers here on Twitch on live, and then I recorded it and talked about when we hear about train derailments, especially on the East Coast, I look for earthquake activity to shortly thereafter follow it up. Usually it's a sign of surface shifting, and they never admit it, ever. They always either blame it on technical failure or whatever. It's happened several times. So when a train derailment happens, I get on and tell everybody, watch out for an earthquake right by there in the next couple days, guys. Doesn't matter where it is. Start to see train derailments, start to look for track shifting. The reason we look for track shifting is because the craton shifts. Professionals don't admit this. You also get mystery booms and rumbles up here in the Northeast. They'll try to cover them as sonic booms. Why are they trying to hide it? Because they don't want to admit there's a flow of anything that goes across anything. Because they said there wasn't previously. They put it in writing. Who's they? Professionals, textbooks, professors, agencies, everybody. They all came out and said there's no flow of anything, no earthquakes related to anything. They all said it, and they said it many times. It's crazy. Anyway, when it happens, they blame the booms and the rumbles on sonic booms. And when it happens and the earthquakes hit after the trains derail, they say it's coincidence. Meanwhile, there's the same sized earthquakes that went all the way across the United States in the past 4 days. 3.9 up in the Northwest, 3.7 down in Texas, 3.8 up here on the edge of the craton up in New York. Compare that to this one more time. Sorry, I have to click back to turn it on. I don't have a hotkey set up. Craton, Northwest, up by Montana, craton edge comes rolling in between the rusty brownish color and the purple color. 3.9 up there, that struck first. 3.7 around the same time, striking down to the south, down to Texas, right at the bend of the craton. And same-sized earthquake within a hair of a point of each other, going up to the northeast. Now check it out. There's no loss of energy, really. Right? 3.9 going in, 3.8 coming out, 3.7 in between. It looks like I lost a little energy going around the bend of the plate, down in Texas. It could be that all three earthquakes are the same and they just did some crazy downgrades on one of them, you know. But we're still talking about the three same-sized earthquakes going across the edge of the craton. Craton. Kraton comes from Kratos, means strong like ox. I get your attention? Class. It comes from Greek word meaning apple. Why you no love me, guys? Come on. Okay, so up in the northwest, on the edge of the North American Craton, going down to the east by southeast, down through Texas, back up to the East Coast. It's a perfect match. It's my biggest discovery. Everybody dismissed it. Professors smacked me in the face twice. Once, twice, back, up, down. They hit me in the uppercut, everything. Never have accepted it. Meanwhile, there's the spread right there in front of you. And we got train derailments now. How long are we going to ignore it? Before, like, how many people are going to have to die and get injured before some freaking egghead professor finally freaking admits he was wrong and tells everybody that? And then that gets the ball rolling on getting the earthquakes looked at across the edge of the Craton, for instance, Professor. I would say that maybe holding me back like that has actually caused harm to people. Like, I mean, just in general, like train derailments and ignoring spreads of earthquakes across the Craton. Okay, all right. Now, enough ranting. Let's go down here and go over into the United States west-southwest. Take a look at the quakes. Quickly take a look and see what's going on. How about a nice stack of earthquakes now on the edge of the Craton in Yellowstone? One more time, that Craton diagram I just showed you. You're just going to have to remember that rusty brownish color on the edge of the Craton comes in through Montana and it goes right through the center of the park. Do you need to see it once more if you're new? If you're new, you do need to see it, so let me make it bigger too so you can really see it. Whoops. Now that's odd. Huh, okay. There we go. Look up in the northwest. See the big black arrow? See where it points to? Points right into Yellowstone Park. But look at the rusty brownish color. It goes right through Yellowstone. Down through Wyoming, down through Colorado, down through New Mexico, makes a bend through Texas. So you got to remember that picture, because that's the way the earthquakes go. Especially once you get down to Texas, you make that bend and go back up into Oklahoma. And you wouldn't know to look for it unless you knew that diagram, or a similar diagram. Any Craton diagram shows it. Anyway, in the Yellowstone National Park, we've got ourselves a nice outbreak taking place. This is not to be confused with the hundreds of tremors that happen every day. There are tremors that happen there daily, sometimes thousands, but they're not earthquakes. They're small vibrations as the magma chamber shifts down below. These are earthquakes, and they're stacked up off the screen now, which is a swarm, as I call it. Any more than 10 earthquakes in a spot, I consider it to be a swarm. And this is an increase from where we were the other day, which was just a handful of quakes. I want to say maybe there was 10 or 15 of them on the screen. Now we're going up off the screen, so it's starting to get excited. I have a warning going here for up to 5.0 to strike just to the west, or 4.5 to strike just to the west over in Idaho. Looks like Idaho's gone quiet. 2 earthquakes in Idaho while Yellowstone is swarming on the Craton. 1 earthquake down next to Sulphur Peak in China Cap Butte, which is a volcanic field, the Geronimo Volcanic Field, down there in southeast Idaho. See where it says Bennington, Ohio? We'll put the coordinates in. We're above sea level, so even though it says -3 kilometers, we're not really up in the sky. We're up in mountains. Let's go take a look. Over here to Idaho. There it is. China Cap Butte, Cinder Island, and the or did I call it the Bigfoot? Blackfoot. Did I say Bigfoot? Ha, if I did. If I didn't, Blackfoot Lava Field. There it is. China Cap Butte, right in the middle of it. Cinder Island out in the middle. Old lava flows. Kind of nestled out there, south by southwest of Yellowstone. Anyway, that's where we are with that lone quake down there. These two are at the Chalice Reserve above the deepest part of the magma chamber for Yellowstone. Yellowstone's magma chamber starts at the surface of the park, where the swarm is, but it goes down below Idaho. That's where these 2 earthquakes are, up above the center of that magma chamber. It's crazy. It goes down below all of Idaho, and the feeders for Yellowstone come in from below Washington and Oregon. Okay, let's go over to Washington and Oregon, take a look. Our only spot now moving for the most part is Mount Rainier, and we're going to put the coordinates in to show you it. I think we are still up in the mountain below the crater. So up inside of Mount Rainier. There it is. Yep. So we're inside the mountain. And it's just small earthquakes, but they're going around the whole thing here. We were below the crater the other day. It doesn't mean it's going to erupt. It doesn't mean it's going to blast or anything. It's a sign of perturbance as the wave is coming in, hits the volcanic chambers, causes earthquake activity. A slight surge in pressure or maybe power in it. I don't know exactly what goes into the magma chamber, whether it's the wave or electrical charge or actually physical pressure that comes in. I don't know. I know it's going in here. That's where our nice cluster of quakes is. Spreads out to a few, which we'll go look up in a second, but spreads right over this way following our arrows and goes into that edge of the craton right by Yellowstone and then goes down to Texas. It's flowing like a river. We could look up the other small earthquakes, like this 1 and 0.8. I don't want to get people too bored here, so we'll just put a couple of them in. Microquakes don't interest everyone unless you start finding stuff at the earthquake epicenters. I don't know what's there, so let's go look it up and see what's there. Whoops. Look it up and see what's there. There is the epicenter, and I don't see anything of any. Oh, wait. Well, that is very interesting. First of all, earthquake next to this thing. But that could just be a dome or bulge that happens in plates. But what we're right next to are these hydroelectric power generation stations. And they're generating a lot of power here. The power is distributed out via high voltage power lines, transmission lines, going out that way and this way to the north and to the south and to the southwest. Right across from it at this is happening over and over again. Let me tell you about what happened just a few days ago. We were up here next to the high voltage power lines that extend off of this and come up and go over to the west. Now we're down here. I just wonder if there's any more of those distribution lines going across here. Of those transmission lines, I mean. I don't see any. Now, what goes on here is with electrical generation, you can get natural earthquakes where very low frequency is attracted to the area. It's not that they're dumping a bunch of power in the ground that causes an earthquake there. It's that there's a natural flow going through here of very low frequency in the ground, electrically induced, Mother Nature. And humans are generating very low frequency power at the power stations and transmitting them along the power lines like a circuit board almost. And that almost guides the wave, I think. I can't prove it. All I know is that the earthquakes are striking next to these spots over and over again. Interesting. Let's go down to the southwest and just take a look. See what's going on down here next to Kalama. Okay. Paste and search. South by southwest we go. What's down here? Mount St. Helens is over to the east. High voltage power lines over to the west. We're about the same. We're closer to the high voltage power lines. But Mount St. Helens, where do these power lines come from? I just wonder. They have a big power generation station here somewhere? Right next to Mount St. Helens, or is it coming from elsewhere? It looks like, oh, okay, that's coming from very far away. Well, I mean, if you were to lean towards something that it's related to, the earthquake to the south, would you think that the volcano it's next to is probably the source? I mean, we are right next to Mount St. Helens, but it's far enough away. Now, I look 40 miles, that's about 5 miles, maybe 8, 10 miles at the most, away from the volcano itself. So that's not terribly, maybe it's more than that. Hold on, I thought it was 5 miles. Nope, it's 18 miles. 18 miles! I always look 40 miles away because magma chambers shift over time. Well, so does the surface. We're going to go down. Oh, hey, look, we got an explosion down here in Oregon again. Oh, man. You guys just, I don't know what's up with you guys and your explosions. They're not quarry blasts. Well, they are not quarry blasts, so I don't know what we're doing here. But getting an explosion at a 3.1 kilometer depth, how do you justify that? That'd be like the deepest mine in the world. Oh, wait. Hey, maybe we have an electrical explosion going on here. Because here's our high voltage power lines again. And it's the only set. Look, we have to go all the way up here to get one set. Is this a road down here? And there's the next set. Okay, there's 3 sets. One earthquake is along it right here. Wow. All right. Interesting, to say the least. Explosion 3 kilometers down in the ground. There's no mine there. And by the way, a mine 3 kilometers deep? No, not there. That's an electrically induced explosion earthquake. But electrically induced is just attracting. But then again, it could be some kind of scalar that happens, a crossing of the waves that could lead to an explosion, I suppose. But Lieutenant Colonel Thomas Bearden tells us that you can get an explosion of energy at a distance when you cross the right waves and the right way. Action at a distance. Down to the south we go. We get down to the Nevada border with Oregon. Let's go see what's going on there. Fort Bidwell. It's listed as Fort Bidwell, California, but it's at the Oregon-Nevada border. That's odd. Let's go see what's going on there. You know, there's something here right at the Nevada border that was kind of hush-hush. I don't know if they're doing it exactly at this spot. Uranium mining. Mining for uranium. Oh, okay. Here's our earthquakes along the ridge right next to Bittner Butte and Blowout Mountain. Bittner Butte and Blowout Mountain. Let's go look at Bittner Butte first. Here's the capped off top of the old butte. That's an old volcano. You can see the lava flows that extend out off the side, the old black basalt. You can also see spots where it still accumulated with that. Look at that. Those are not bushes or anything, guys. Those are rocks. Here's a spot where there's a fissure apparently at some point in the past that broke open and flowed. It's so old, though. Now, next to it is the younger Blowout Mountain that blew out at some point in the past. Whenever I see earthquakes up here on the north side of Nevada, I look out in the ocean for new activity to strike. Usually, there's tension that builds up, or a wave builds up, in between North Nevada and out here in the Juan de Fuca fracture zone. The Juan de Fuca fracture zone is this giant letter M-shaped fracture zone out here, and the sawtooth edges belong to the Pacific Plate. So there's another plate that's the remnants, they say, of an ancient plate. I say this is just a broken edge of North America, but whatever. You see the sawtooth edges, those belong to the Pacific. They push in, as the Pacific is in motion, much more than Laurentia, and they push in, creating that tension, and that wave comes right in through the Juan de Fuca fracture zone and goes into North America, goes into the Craton. So, anyway, we're going to see a new push break out here, most likely. I don't know if they're going to report it. There's a lack of reporting of earthquakes out off the coast for national security reasons, in my estimation. Down into California we go. I have a warning going down at Salton Sea for up to 4.9. I'm not changing the forecast at all. We're watching in Southern California, Salton Sea area, for a new outbreak, a swarm, and 4.9. That's based upon all the other 5s that were going around the plate when I issued the warning 3 days ago. We get here into LA. We're moving back by the old pumping operations. Out off the coast, there's nothing out there, as far as I could see, unless there's some kind of new pipeline or new oil pumping operation out there that's just not on Google Earth. The lines of earthquakes going along California's coast are, well, we all know about the San Andreas, but they're creeping down the San Andreas, beyond Parkfield. Normally, we jump over into the valley and then go down to the south tip of the valley, which is happening, but a bunch of earthquakes are going down the San Andreas itself, and look what's happening. North LA is starting to light up. 2.8, 2.3, energy's coming in on the San Andreas. Let me show you where it's coming in from. Turn off all the place marks. Here's the San Andreas everybody's familiar with. Bunch of earthquakes coming down. Normally we stop right about here at Parkfield. We jump over into the valley, over to the drill points. All the oil and gas drill points. But we're not doing that now. Now the earthquakes are coming down. It's straight up going into North LA. North here, just north of LA. Now, there is a jump over that's happening, but you can see it. It's just small. 1s and 2s jumping across. We got 1s and 2s coming down. We've got 1s and 2s in North LA. And if we go in and look at these earthquakes here, we're going to find we're next to old drill points on land. Several of the spots are next to drill points. Over here across the valley, same thing. We're going next to drill points, at least in the valley. Once we get over to the east of the valley, we're back to that fire location where the fires happen. Okay, it is what it is. The earthquakes are spreading over to the fire location. The earthquakes are spreading down to the oil pumping operations in LA. Now, I'll pull the earthquake in the middle of LA. It just says east of Los Angeles. And you guys are welcome to go fact check. You can go look these up if you need to. The way you do this is easy. You get the coordinates from the US GS and just put them in on Google Earth or any map looking up software that you can. But I would use Google Earth just because it allows you to zoom out, zoom around, see what else is nearby. Turn on your, layers and so forth. And okay, so here we are, North LA, right? So do you know about the history of the location right here? Ascot Hills, all of this? This all used to be drilled. They have now turned it into an industrial park, Dodger Stadium, and so forth. Okay, this all used to be drilled. It's a well-known fact. They may even still have a few functional wells. I don't know if they will. They may still have a few functional wells placed out around here on the greater grounds. I wouldn't fully bet on being able to see them from aerial. You guys can, again, fact check me on this if you need to. A kids' playground. They will have oil wells right next to kids' playgrounds out here for sure. Anyway, okay, so backing it out, it's a well-known, a well-established fact. This is one of the biggest old oil fields in L.A. Ascot Hills, let's see if we've got something there. I don't know if they'll have old wells there still. They got the reservoir, right? Ha! How ironic is that? You know how they used to cap off the wells? A bag of concrete and a wood plug. And dirt. All right, well, I'm not having too much luck finding any examples of wells. All just to tell you that it was previously drilled about 10,000 times or more right through that area. The pictures are impressive. So that's the spot, the old oil field. Okay, wow, that's where we are in L.A. What about north of L.A., up here, 1.1? Agua Dulce. Agua Dulce. What's up in Agua Dulce? Let's go take a look. There we go. Okay. Once again, mountainous area we would expect fault zone movement in. What I look for are any man-made things that might stand out. Nothing go wrong with this. Watch this. See all this? See, first of all, you see Castaic Lake with its big dam? Okay, right here is a big oil pumping operation. All right, you see one of the wells right there. It goes all across where all these little pads are in the ground. Goes up and around, up into here. Pipelines, jacks, pumps, and so forth. Goes all the way around, okay, on this side. Now on this side, I don't have any marked wells. I haven't bothered to look. But if I looked, I'd be willing to... Oh, hey! What do you know? It just so happens to be the large switching station, electrical switching station for the region. The Haskell Canyon switching station, right there. Okay. Now, I wonder if there's any other things that are here nearby that need identifying. I love finding stuff like this, guys. Okay, so finding the oil wells, obviously oil well drill point. I look 6 to 10 miles. So that might be more than 6 to 10 miles over to the drill points. The reason I look 6 to 10 miles on the drill points in particular is because of the amount of drilling they can do out at an angle. We're 14 miles. And these literally go right up to the road here. Now, are there any on the other side of the road? Now, there might be, or there may be closed old wells that I'm just missing. Oh, yeah, I'm missing. Look at that. Well, all right, let's keep going over to the east. Wow. Whoa. Yeah. Wow, what are we doing here? What do we got going on there? Is that a glamping ground? Is that a glamp ground next to the landfill? Is that how you guys roll out there? You're going glamping next to the landfill? Or is that a quarry? Anyway, let's go down to the south. More drill points. Okay, we're getting pretty close. We're definitely closer. Okay, let's just back this off a few miles. Now we're down to 12. Are there more? There probably are. Where there's one, there's more. Here's our high voltage power lines that go through the area. Okay. They come right across. This is how we do it live, by the way. If you're watching and you've never seen me do this before, I'm trying to get this down and see if it's related to the drill points or not. On the east side, it's just taking us right out to the San Andreas. Now, I think it's pretty foolish to be drilling right next to the San Andreas at all, or next to a dam. Are you shocked to find out that we're getting earthquakes next to our drill points? It's a matter of a mile. I'm trying to shave it down. I look 6 to 10 miles. We're at what, 11 or 12? They can drill out by 5 or 6 or 10, 12 miles. They'll tell you they don't. Oh, they never do. Oh, we don't drill that far. Never. That's impossible. I had a guy contact me from an oil company directly and tell me they can drill up to 5 miles laterally after they drill down a couple. And they'll drill down a couple at an angle first, and then they'll turn it sideways and drill another laterally out 5 miles. And I thought, wow, okay, if they can drill out laterally 5 miles, and they're going down at an angle to begin with, and a couple miles, that's taking us out to like 10 miles. So I should start watching out about 10 miles to see if there's any fracturing that happens out and away from a big, long, horizontally drilled well. Everybody knows about vertical drilling, up and down, drill into the ground, go down, but they can turn it at an angle and start cutting arcs through the ground. It doesn't go at a hard right angle. They turn it at an arc, and they cut like in bends. They can bend it up and down like a snaking pattern through the ground. It's crazy. I'm not against oil and gas either, but when we start seeing a bunch of earthquakes strike next to them first, before we get a 5, before we get a 6, it's a sign. We can use them, even though they suck, we can use them for a sign to let us know that there's an incoming wave. Start seeing a disturbance at the volcanoes and the drill points. Pay attention, because that means something's coming in to disturb them. And what's coming in to disturb them? The same force that's traveling down the plate and causing the disturbance at all the other locations that I haven't even bothered to look up yet. Our nuke test sites down here in South Nevada. Another example. Man-made faults, cracks in the ground from nuke testing. And they're getting hit now with small earthquakes. But why? They're not doing nukes there now. The arrival of the wave is going to the nuke site, just like it's going down to those drill points that I just showed you. Here's the nuke sites themselves. Here's where the earthquake epicenter is. And we will open up the Google Earth Gallery to get the information on the nearest crater and the test in it. U.S. nuke Operation Futuk. June 8th, 1975, 20 kilotons. That's the nearest one marked. U.S. nuke Operation Wheatstone Canvasback. August 22nd, 1964. 18 kilotons. Right across the road, Operation Aardvark. May 12th, 62. I don't know what kilotons this designates at. 7S40. I have no idea. I don't know what that means. Anyway, all these craters are different underground nuke tests. The reason it's getting hit now is because the wave that's going down the San Andreas and going into the oil pumping operations and hitting into LA, same wave is coming down the California-Nevada border and dead-ending into the the nuke operations. Pumping operations, nuke operations. What do they have in common? Both are fracture points at the surface that humans have created. But if you look back up through California, these spots are Mother Nature created spots. Volcanoes and the San Andreas Fault. Volcanoes over in eastern California, San Andreas Fault in western California run along the coast. Creeping section of the San Andreas, all the way down. And then back up here, this big stack, volcano. The geysers of California. Mount Konocti. Let's go put the coordinates in. Go take a look. Here we go. All right, there's the pipelines, and those pipelines are containing steam. Steam goes to the turbines. Turbines are providing power for the area. And heat is coming from the volcanic field. Clear Lake Volcanic Field and Mount Konocti. But really, that's just the mouth of the river of the San Andreas that's fed from the greater tributary out here, seismically speaking. Anyway, it all points down to Southern California, where we're looking for a 4.9. California-Nevada border, nothing's changed there except for the number of earthquakes, and the magnitudes are going up. So the number of earthquakes and the magnitudes. What does that mean? Increase in power, amplitude. They're turning up the volume. If this was a drummer beating a drum, they're now beating it very fast, and they're actually kicking in the bass drum a little bit, or hitting some toms as opposed to just a snare drum. So we're starting to increase. 3.5. Stacks of earthquakes, swarms, all pointing down to Southern California. Now, final thing I'd like to point out. The spread of earthquakes going across the United States, again, one of my biggest discoveries, that the seismic flow goes across the U.S. Once we start to see an increase near 5.0 on the West Coast, guess who else is going to light up across the U.S.? We're going to see a definite increase down in Texas again. I have to warn Colorado right now, so let's just get the warning out to Colorado. Watch for 4.0 level activity. Down south, down by Trinidad, also Texas, 4.0. Both should get hit. As we go over between Oklahoma and Arkansas, Arkansas should also start to move. So might see a new rare 4.5 to 4.9 near 5.0 strike between Oklahoma and Arkansas on the southwest side of the New Madrid seismic zone. Over on the East Coast, we're going to have to warn Virginia for this week. So Virginia now is the halfway point. Look where the rings overlap. That's the state of Virginia going into North Carolina. But state of Virginia, Western Virginia, edge of the craton, magnitude 4.5. Maybe bigger, but I'm going to put them at 4s right now. So it should be 4s going across the plate. It's based upon what's going to be striking over on the West Coast, which I think goes up to 4.9. Now, you guys want to end it on a fun note? I said I was going to show you something at some point, an underwater base. You want to see an underwater base? It's not, the mainstream media tried to call this a UFO base. But I found something. But to see what I found, I have to show you something else I found. This is a great way to end the video. going to bring you in here to my neck of the woods. We just turned the United States on its side again. I'm going to bring you in here to St. Louis, Missouri. Let me turn back on my borders and labels. See, here's St. Louis, Missouri. Okay. I live right out here. All right. Anyway, let me turn all the borders and labels off. So, here's St. Louis. And what I want you to see is this 5-sided thing here. 1, 2, 3, 4, 5. Or you could say it's 1, 2, 3, 4, 5, 6 sided. But I think it's 5. It looks 5-sided. St. Louis is on this side. Guess what's down here? New Madrid. And another one. Now, these are made out of mountains. This is 6 miles by 9 miles. And the town of New Madrid is right here. This is the town of New Madrid, Missouri. Okay. Now, a series of earthquakes started striking. Of course, we all know about the New Madrid earthquake. But started striking here in the town on the other side of New Madrid, like right here in town. And there's an Indian mound that it's striking at, which is very odd to have the earthquakes below the Indian mound. But then I found this, which is in that classic star fort shape, 6 by 9 miles, and this is next to this huge one that's ancient. It looks ancient and old. Now, what does this have to do with the West Coast and an underwater base? Well, St. Louis is here, and the town and the other star fort, or whatever you want to call this thing, bastion fort looking shape, 6 by 9 miles, made out of mountains on the other side. St. Louis on one side, this on the other. Now, over here, on this side, we have Columbia, Missouri. Let me turn my borders and labels back on. Or Kansas City, I mean. Here's Columbia, Missouri on this side, on this point. Now, we go up to the pinnacle tip up here, and there's Muskogee, Oklahoma. All right. Now, why am I taking the time to show this to you? Let's turn off our borders and labels. And I'm going to measure a line from the back here, right in the middle. And, oh, by the way, on the back side of here are the Great Cahokia Indian Mounds, right here. Right across the river from St. Louis, just north of the airport. Okay. Anyway, the big Indian Mounds and the St. Louis Arch are right back there, the gateway to the west. So we're just going to measure from the back side of here, and we're going to go right through the middle of it like it's a giant arrow pointing us to something. We're just going to carry on all the way out. We're going to keep going past the United States. We're using it like an arrow. Okay. And it just points us out there into the Pacific. Okay. Now, we're going to go in. You're going to think I'm nuts at first until I show you what's here. Coming in the same path is this. Now, previously it was said by the mainstream media that this was a mismeasurement by using underwater bathymetric measurements, and that this was just nothing. Okay. Other people weighed in and said that they saw something there, and the media weighed in and said it must be from UFOs. Now, I decided to take my mouse and measure the actual features here to see what's going on, because these are raised in many cases, not from bathymetric C measurements getting some kind of sounding that's a wrong sounding. So when I move my mouse over these, we are here at the sea floor at 4,756 feet below sea level. And we come up and we go 200 feet high. These are 200-foot high mounds of some kind. All right. Now, these are made. These were made this is 5,000 feet below the sea, guys. Down in the Baja Peninsula of California, or Mexico, off the coast of Mexico. And this is really there. It's really there. It's not, like, for instance, our measurements here go 4,236 feet, and then we go up to 4,400 feet. And then we go back down to 4,200 feet again. 4,100 on one side, 4,100 on the other, and then 44. It's 300-foot rise. All right. Now, I wasn't expecting to find this. I found this and just wanted to know where it pointed, and I thought it was really weird that the New Madrid seismic zone was on the left side of this thing, and that this was here. I thought that was weird. Okay? I have to show these things to you because guess what happens down below right here at the pinnacle tip of this thing? Let me bring it back due north. Right here in Oklahoma. That's the bend in the craton that gets hit with all the earthquakes. Right? And then the back side of this thing, where the thing is that I showed you, in town of New Madrid, and the Indian mound getting hit and so forth, that's on the back side here. So the front pinnacle tip and the back side of it is getting hit with earthquakes. What would you do if I told you that this is happening all over the planet this way? And I found example after example all over the world with this happening, with the earthquakes especially. That's what's drawn my eye to them. So while before you think that it's some kind of weird conspiracy or something, I think there's some natural explanation for the frequency, at least. Very low frequency, but who could build something like that? That would have been built at some point in the past. Who could build with mountains? Bigger than mounds. It's 5,000 feet down in the ocean, too. What is it pointing to? Is that some kind of transit system? I don't know. I have no answers for anything that I just showed you other than to show you that there are actually physical features. There's earthquakes striking next to each one, and they're in a certain shape. That's a fun way to end this video. So, do you guys have an earthquake plan? Now that you're fully just completely desensitized, and your mind may be blown or you might be incredulous. Whatever. You might be just completely incensed, whatever it is, at what I just showed you. But do you have a plan for earthquakes? To know what to do when an earthquake strikes? Like the people in Turkey, for instance. Some of those people had an earthquake plan. Over in Europe, you need to have an earthquake plan. Over in Italy, don't ignore it. Take this time to dust off your emergency kit. Hey, don't ignore the warning that I issued for Virginia. Don't ignore the warning that I issued for over in the West Pacific. Down in New Zealand, don't ignore it. Wait. Wait and see till the earthquake strikes. On this 7.8, we waited 14 days. 14 days came and went, and then on day 15, 7.8. You can watch for it. You can be prepared, but when an earthquake hits, I think it's just going to be a matter of, are you able to get out of your structure if it collapses? Or are you able to take shelter underneath a table or a desk to prevent injury? That's what it's going to come down to. You need to know what your surroundings are. I'm not trying to get all preachy and lectury, but it's an important go time right now. Why would I take the time to show you that there in Missouri? People tell me that that would call my credibility into question when I show you these kind of things. Well, the greatest earthquake in the United States struck on the side of that. The New Madrid earthquake struck on the side of those features. How could I ignore it and be a good seismic researcher to notice that that thing's pointing towards something else that's extremely odd that keeps getting hit with earthquakes out in the Baja Peninsula down by Mexico? That middle point of the Baja Peninsula right there. That keeps getting hit with 5s and 6s and so forth and large earthquakes. You can't ignore it. Or you could, but it would be foolish too if you're into observational science. I don't care where it leads me. If it leads me to some ancient civilization that built plates somehow with cymatics and very low frequency, so be it. Over in Turkey, we can't ignore the radar. We can't ignore the low pressure system, the power differential between the two. That there could be the Earth spot thing that SO is talking about, suspicious observers. Or that the radar stations could be getting punked by directed energy weapons from space. If you ignore that kind of stuff, you are going to be ignoring a good part of what science is now, which is next generation stuff happening under your nose or above your head. And the denial of it at the same time by people who either are gatekeeping it, like they know and they're hiding it, or they're deliberate dupes and they just repeat the line of everybody and just repeat what they hear in the media and feel good by shaming you. I'm just telling you, you can't ignore this stuff. If you do, you're never going to make any new discoveries in the world of geophysics. To all my viewers and everybody else out there listening, you got to pay attention to the small stuff in order to catch the bigger things. 8:58 p.m., not trying to get too preachy. I'm glad I used that example on the New Madrid as something that you guys can look for around your area. I don't know about Turkey. Maybe people should look over in Turkey. I will too, and analyze the area, see if there are any of these ancient features that are there. Giant mounds or big structures that are built that nobody can explain. I'm not getting paranormal on you. There's a natural explanation for this. Very low frequency, directed energy through the crust. But it would mean somebody a long time ago had knowledge of this. That's all it means. I wouldn't be surprised if they did. Anyway, 9 p.m. right on the money. I'm out of here. You guys be safe. Much love. Don't be scared. We need to be prepared as the 6.0 level activity is getting ready to go across Europe. Italy, Albania. You already have a 4.9 right on your doorstep and a 5 out in the ocean out to the west. You're sandwiched between the two. Scotland's moving. Europe is on the high alert right now, going in the other locations. If we do not see the spread go across Europe any more than it has now, we're going to get a new earthquake back down in Turkey somewhere in that big letter J shape of a plate boundary that's forming that nobody wants to talk about except me. Why is nobody talking about it? Seriously, why is nobody talking? Where's the proof? Anybody know? I'm not trying to get too whiny or anything, but come on, man. Where is everybody? There's seriously like a new plate boundary. Looks like it's forming across Turkey with that big letter J shape. And I'm the only person talking about it? What the hell kind of world am I living in? Is everybody scared or something? Oh, they're going to hold it against me if I'm wrong. It's an honor in science to be wrong and correct yourself. It's okay to throw it out there to look at. All right. Much love. Save this as a video. Time to put it out over on YouTube.